Hello, everyone, and welcome to Physical Chemistry. So the point of today's lecture is to kind of get you familiarized with what to expect out of this course and get you familiar with the video lecture process. So as a general background into the course in general, we're going to be making use of four major assessment techniques throughout the semester. And so each one of these is going to be focusing in on a slightly different idea. So first of all is going to be web assign. So this is our web-based assignments that most of you are familiar with. And one of the biggest focuses of this is going to be giving homework problems that give you a lot of time to practice some of the concepts being covered in the video lectures and in class, kind of independently and with constructive feedback from the system. However, if you ever find yourself getting stuck on a web assigned problem, feel free to work with those around you. And I'm always here to help, especially on some problems. Having a little extra guidance and direction can be really important. The next major technique is going to be quizzes. So these are going to be administered every Friday. Tentatively, these will be administered as take-home quizzes because I cannot guarantee that everyone will be able to make it to class every Friday. And one of the biggest things they're going to focus in on is questions with less straightforward numerical answers that are harder to give in WebAssign, and especially problems where where even if it is a numerical answer, the work becomes a lot more important in the assessment technique. Now, one of the big things to realize is that the quizzes will, by their nature, be a little bit harder than what we've covered in class lectures or on the web assigned homework. And one of the biggest reasons for that is as long as they are online, by the very nature, I have to make sure that they can't have a simple Googleable answer, which means that they're going to be a little bit trickier. However, as compensation, you get as much time as you want, and you can go ahead and and feel free to make use of all the resources you have to find similar problems. And I will actually tell you that a very common format that I use for the quizzes is I take two of the harder web assigned problems and stitch them together, or two of the problems that I noticed that people could use a little bit of extra work on the in-class portion. So again, these will often be familiar, but in a very different format. And again, with a couple tweaks in there so you can't just Google the answer. And finally, we're going to have the exams, which are tentatively scheduled to take place in the middle of February, first Friday and the first and last Fridays of April. So these, I try to make sure that they cover both concepts and problem solving. And the exact format of the exams are probably going to change as we learn more about what we're allowed to do in class and outside of class, what with COVID raging. Though tentatively, I would like to try and have a small portion of especially concept-rich questions, maybe multiple choice, fill in the blank, or short answer, in class, and then longer problem-solving portions do essentially over the weekend. That way you get a little bit more familiar with having to study for some exams, which will hopefully provide you some extra benefit when it comes to the final, which is going to be a good old-fashioned ACS final, and that's going to be on May the 4th. So May the 4th be with you. And again, this will be the typical typical 50 questions in 50 multiple choice questions in an hour that you may be familiar with from ACS exams and other courses. So hopefully nothing too unforeseen with that. Now, the other thing I want to kind of go over with is what's going to be the general overview and focus of the course itself, the material we're covering. And I really want to do this because it turns out that we're going to spend a lot of time in the very technical weeds this semester. And I kind of want to show how it all kind of comes together. So the semester can really be thought of as covering two major separate features. Both of them are going to be related to essentially the quantum mechanical nature of molecules and chemistry in general. And it turns out that in order to understand a lot of the nuances of chemistry, you need to have a good background in quantum mechanics. And so we can split this into two major focuses. The first of which is going to be very structurally based. So if I know my basic quantum mechanical principles, I can use this to determine the electronic structure of atoms and molecules. And once I know electronic structure, I can get a lot of information about uh, molecular structure and about behavior, because it turns out that in chemistry, electrons really do dictate everything. And then the second part of this is going to be how we can determine these various electronic and molecular structures, mostly using light, because it turns out that electrons are, again, a charged particle. And it turns out that light interacts very nicely with charged particles. So one of the dominant features of trying to understand chemical structure is to use light to figure out electronic structure, and thus we can see how everything kind of comes together. So spectroscopy and structure, these are the two kind of cornerstones of this semester of PChem. And so we're going to kind of split this up as we walk through the course through essentially 5 different chapters. So the first major focus of the semester is going to be on basic quantum mechanical principles. This is going to include we'll start off by examining the behavior of light, then work our way to general quantum mechanics, and then we can start applying this to small molecules and electrons. So this is going to mostly be covering the material in chapter 7. I'm going to bring in a little bit of chapter 12, spectroscopy, chapter 11, spectroscopy, to essentially illustrate some of the direct applications of quantum mechanics. And it's worth noting that this key principle of understanding our basic quantum mechanics is really going to underpin everything else we do. And as a consequence, I'm going to spend about a third of the semester just on basic quantum mechanics. So it's going to be kind of important to understand what the applications of this are, so we don't get too lost in the weeds, because it is quantum mechanics. So the first application we're going to apply this to is going to be chapter 8, and this is essentially atomic structure. So this is going to be taking a lot of what you've learned from 131, and again, fleshing it out with a lot more details, a lot more information about exactly how electrons interact inside of an atom. Now, once we get the behavior of both hydrogenics, so atoms with a single electron, and general multi-electron atom behavior, we can then try and slowly extend this to what happens when I have 2 or more atoms. And this brings us to chapter 9, which is going to be a lot of molecular structure. So again, a lot of the emphasis is going to be on the electronic behavior inside the molecules, because again, if you know where the electrons are, they determine everything else. However, one of the things that I'm going to be trying to sneak in both of these chapters is the relationships of these structures to the behaviors of the atom, so that it isn't just solely existing in a vacuum. However, the book does not emphasize this quite as much, so I'm going to tend to include more of this in the in-class problem solving, where I'm going to try and come up with as many applications of the basic concepts as I can. However, at this point, you're going to quickly notice that the math starts getting a little bit out of hand. So one of the ways we can simplify a lot of our mathematical equations is we're going to come back and look at these basic principles using symmetry, which essentially turns out to be a mathematical shortcut of truncating a lot of our equations. However, this is going to involve a little bit of different fields of mathematics you might not be quite as familiar with, such as linear algebra. And I'll try and bring it up as needed. But again, one of the biggest things is that symmetry is going to be our savior at the end once our equations start getting a little bit out of hand. And again, this is going to be mostly covering Atkins chapter 10, which then brings us into chapter 11, which is going to be spectroscopy. So I'm going to take a lot of the basic examples of spectroscopy I brought up in chapter when talking about quantum mechanical principles, And then I'm going to use a little bit of the information we've gained from molecular structure, along with a lot of the shortcuts from symmetry, and hopefully bring them all together to help describe some of the spectroscopic behaviors. And then again, if I have enough time, we'll bring up a little bit more, we'll dive a little bit more into a specialized field of spectroscopy, and that's NMR, where instead of using light, we're going to be using magnetic radiation to really probe the structure of an atom. So again, first third of the semester is mostly going to be spent on basic quantum mechanics. Second third is mostly going to be on structure of atoms and molecules. And the final third is going to be kind of wrapping everything up, especially with some focus on symmetry, spectroscopy, and hopefully a little bit of NMR. So that's going to be the general form of the course. See you next time when we dive into the behavior of light and the dawn of quantum mechanics. Until then, take care.